Brian and John with LightPointe on, and they're going to be going over the slides here. So any questions, we're going to hold those for the end, but you can type in your question in the bar, and once you enter it at the end of the presentation, we'll answer any of those questions for you. Alrighty? So without anything else, here's John with LightPointe.
Good morning, everybody. This is John Taylor with LightPointe. I'm the Vice President of Sales, and this is the first of a series of webinars that we're doing on LightPointe wireless bridge technologies, which includes free space optics, or FSO, and millimeter wave. We'd like to thank Microcom for this invitation to speak to everyone, and Jeff, thank you very much for the invitation. LightPointe produces a suite of high-capacity wireless bridges. We offer a complete line of 60 as well as 70, 80 gigahertz band radios. We offer a line of FSO, free space optics, and wireless bridges. We also have a line called the Hybrid, which includes our all-weather hybrid series, and we've been in business since 1998. We're celebrating our 15th year. And as of this month, all our products that are registered will have a 2-year warranty, so you get an excellent value for your investment. Brian Peterson is with our customer service department, and today he's going to go over the simple, good install practices of an FSO system. So I'd like to introduce right now Brian Peterson with LightPointe Customer Service.
Good morning, everyone. As the front slide will tell you, we're going to talk about hardware installations, and we're going to focus specifically today on our FSO products. Let me see if I can... There we go. As John mentioned, we started off in 1998, and over the years we've gone through a very strong progression of product development, including some product innovations with our hybrid products, and also joining in with our FSO product line. As John mentioned, we have our AirBeam products, which are millimeter wave. To give you a little overview of our optical products, we have a full suite, starting off with our Strata product, which is our multi-beam, multi-receive product line. It also has automatic gain control in addition to tracking. We also have our AirLight series, which is a smaller compact product, which is used for shorter distances. And I'll talk a little bit more about those products as we go through this. And then, as I mentioned, we have our hybrid series, which is gigabit Ethernet for the free space optics or laser component. And then we use a multi-frequency rate adaptive solution with an RF integrated backup radio. In addition to our free space optics, we do also sell and support millimeter wave products under our AirBeam product line. These are using millimeter wave in the 60 as well as the 70 and 80 gigahertz bands. A little bit different than free space optics. The distances are longer. The bandwidth is the same. It's still a gigabit, just like our free space optics products, but it does offer a different type of frequency to be used to go longer distances. So really what we're going to talk about today is FSO. We're going to talk about the beam characteristics. We're going to talk about where you look to install these, how to do the installations, and best practices in general. One of the things that is important to understand about free space optics and laser-based solutions is the narrowness of the beam. Now, that narrowness of the beam is extremely beneficial in that it gives you high security. It gives you a very known beam. You don't have to worry about Fresnel zones. If you've got a clear line of sight, you can get the signal and your bandwidth across to the remote side. But it is a tight beam. And to give you an example, our widest beam products are 5.7 millirads in beam divergence. Our middle of the road, our AirLight Gs, transmit at 2.8 millirads. And then our most narrow beams, the ones that go the longer distances, are 2 millirads. Now, because 2 millirads is a very narrow beam, we include the automatic tracking with those products. And to give you kind of a point of reference to the narrowness, especially if you've done other types of wireless bridges, 1 degree equals 17.5 millirads. So even our widest beam product is still only 1/3 of a degree wide. And our narrowest product, as you can see, is only 0.114 degrees wide. Very narrow. But it also allows us to squeeze through very narrow places and not have to worry about Fresnel zones. When you do go to such a narrow beam, it is important to have tracking. And what does tracking do? Well, the tracking actually will help compensate for building movements, also known as a diurnal movement. So as a building heats and cools and expands and contracts, it will move. And it'll only move maybe a fraction of a degree, but given the beam's diameter, if you don't have one of our wide beam products and you've gone with our Flight Strata product, you have the tracking to compensate. And as you can see, the tracker actually compensates for almost 1.5 degrees of building movement. To give you an idea visually of what that means, so when you have one of our beams or one of our systems at a given distance, you can see the small red circles. That's the beam's natural diameter based on the beam divergence at a given distance, and it's a very defined and calculated pattern. Then you throw in the ability to have tracking, and now you can see just how much, with those teal-colored squares, how much more coverage the tracking units will provide, how much more movement they can tolerate on a given installation and still maintain signal strength. So doing a site survey is important for any solution from LightPointe that you do. It's important to actually physically look at where you're going to be installing. Because we are a true line of sight product, you can't have something that's near line of sight or, oh, well, if I squint. No, you do need to have true line of sight, and you need to be able to see the other side. Our most common method of installation is a standard point-to-point. And even when we move to the middle configuration, which we're calling a multiple point-to-point, really what you have is 2 point-to-point solutions all coming back to building A. So building A is the headquarters. You would have a system going to building B and another system going to building C. We don't have an omnidirectional product that would be installed at building A. We have 2 individual products pointing directly at the remote buildings. Another option that people do is a back-to-back solution, and this can be done for 2 reasons. One is to expand the distance, using building B strictly as a hot point in order to increase the distance to be able to get to building C. Or you can use building B as a drop-off point. So you go from building A to B, drop off some bandwidth, and then move on from building B to building C. Really depends on the installation that you're doing and what you need to do. In our point-to-point configurations, the most common way to do this is in an outdoor roof-to-roof configuration. When doing this, and you're looking at our product selection, what you need to do is understand the distance between the 2 buildings, which you can do through Google Earth. But in order to verify line of sight, you do need to go on and physically look. But we also need to know kind of the angle that you're shooting at. And we'll talk more about why angles are important in a minute. Another option, if your buildings are close enough and you have windows that are not overly tinted, you can do a window-to-window. Now, as I mentioned, we have to talk about angles to the glass, we have to understand the distance, and we have to understand some information about what kind of tinting is on the windows, because the tinting will add attenuation, removing some of your fade margin, and depending on the type of coating that's on the windows, it could reflect the signal. So it is important to understand what kind of coatings are on the windows. There are times where you'll have clear glass on one side, but a coated window on the other side. It may require that you do a window to roof configuration. And again, if that window, the one behind the glass, has clear glass, you'll have a nice, easy installation. If it has tinting, we do need to understand what kind of tint and how much attenuation it may have, and what kind of effect it will have on the signal strength. Now, some additional factors when doing a window to window or window to roof are the angle limitations, and this has to do with bending of the light as it passes through the windows. You want to stay as close as you can to 90 degrees to the window. So as square and perpendicular to the window as you can be, the better off you will be. And the reason for that has to do with the refracted light and the reflected light. Especially if you do have double pane windows, you can see you'll get a double bend to the glass. So if your angle as shown in the upper right hand corner is too extreme, you'll see that it actually bounces off of the glass as opposed to penetrating the glass. Now there are some other things to keep in mind because we are a true line of sight product and we are using infrared beams to transmit our signals back and forth. It is important to know what you're shooting across or shooting through. And again, a physical visit to the site and doing a real site survey will easily let you see where you're shooting and what you're shooting through. So smoke, fog, steam, those types of things can cause certain amounts of attenuation. So it is important to know how far you're shooting and what you're shooting through. Now getting back to the angles, aside from glass and how the angles to the glass can affect this, up is too high, you can actually get pooling of water on the unit that's facing up. And what the pooling of the water will end up doing is causing the attenuation. In other words, as the signal is passing through the pool of water, it actually is bending and attenuating the signal. Additionally, if you do have it pointing up too high, you will see that it will get some sun blinding. In other words, it comes in and it overloads the receiver because of the sun's intensity. Now that won't happen all day, every day, but it will happen if you have an angle like that for a few minutes during certain times of the year. One thing that also happens when you have an extreme angle is you will find that debris will actually accumulate on the front faceplate of the glass, and you'll need to go up and do a wipe down of that glass plate more frequently than if it was not at an extreme angle. Additionally, you want to make sure that you install as close to the edge of the roof as possible to avoid scintillation, which could bend the signal strength. Now all these things are just to keep in mind during your site survey. All of them can be compensated for, and all of them have been compensated for to create extremely successful long-term installations. Now one that does creep up every once in a while, and this is for all line of sight solutions, installing where there's foliage that can grow, those trees can impact the line of sight. And maybe it'll be in 3 years, 5 years, 10 years, but if you had a great signal strength and then all of a sudden springtime comes and now you're seem to be having some outages, it could be something as simple as the tree has grown or the leaves have come into bloom. We also run into this occasionally, and again, this is a general rule for all line of sight type products, is if you have a construction zone that pops up between your two buildings that you're connected to, anytime that they pass through the line of sight, they can cause a disruption to the signal. Now the signal is going to come right back up and the data transmission will restart, but those of us who use voice over IP phones, if you get those even brief interruptions, a couple packets doesn't drop the call, but you will notice that something has passed through the beam. Line of sight, again, this happens slightly more frequently where you install on a building and they tell you, uh-oh, you know, for aesthetic reasons you need to be off the edge of the building. You need to be back more towards the center so that we can't see it from the ground. Well, that's okay, but if you install it at a low position, then the next time that the guys are up doing air conditioning work or roof work and they're passing back and forth, our stuff doesn't look like it's a microwave. It's not a big dish. It's not a very obvious thing. It looks like a large mailbox. It looks more like a camera than it does an actual data communication device. So therefore, them walking in front of it, they won't think anything about it other than, oh, maybe someone's taking a picture of my knees as I walk in front. So if this is a situation, you will want to raise it up to a level that will allow the workers to get their work done and still be able to keep your signal going. Now, depending on the product, some of our older Flight Strata products, if you've installed LightPointe products in the past or familiar with them, our Flight Strata products were AC at the roof with a DC converter plugging in. Now, we've moved away from that with our newer Air style products, and now all of our Air products are power over Ethernet. So now all you need is a simple Cat5, Cat5e cable to provide power and a second Cat5e or Cat6 cable for the data. Much cleaner, your PoE stays indoors, and the installation is a lot simpler. You don't need to get with an electrician or an electrical contractor or anything of that nature. Now, if you do have a situation where DC power already exists and you'd rather run off of the DC power, maybe you're installing on a building that is running off of generators, no problem. We do have DC to DC converters that you can use in order to power our systems. Things to keep in mind when you are preparing your installation: if you decide to go with fiber, which you don't have to, our AirBeam, all of our Air products do have the ability to run off of an all-copper solution, but there are times where you're going to exceed the 100-meter limitation of copper, and in that case you may need to go to a fiber solution. Or you may have fiber that already exists from a previous installation and you just want to reuse that fiber. No problem. We use an SFP, and it's an open slot, and you can plug in whether you need multi-mode, single mode, or if you want to do another RJ, you can do 2 RJs. Just make sure you're using the properly rated product, outdoor rated. If you're going to do multi-mode, you want to make sure you keep that at 2 kilometers or less. Single mode can go significantly further. And depending on the product, we either have SC, or if you're doing one of our newer products, they're all LC connectors. In my, 11 or 12 years now with the company, one of the things that is the biggest challenge with fiber is broken strands or poorly terminated connectors. So these things happen frequently, and they happen to the best installers I know. So if you are doing a fiber run, try and run an extra strand or 2 just in case. Now, copper wire has become the most popular method for installing our products since we developed the Air Strata products as well as the Air Light products. And with that, you can do just a standard twisted pair. You do want to use outdoor rated cables, terminating with RJ45s. Most people can do that without a problem, or by pre-terminated. And then you want to do Cat5e or Cat6 cabling. Especially on the data side, again, this is a 2-cable solution, so it's going to be 1 cable for power and management, and then the second cable is for the data. And so for the data, you want to do Cat6 so you can take full advantage of the gigabit Ethernet and get your best throughput over the best lines. Now, during these next few slides, we're going to talk about mounting. And mounting is the most critical aspect of the installation. Once you've picked your product and you know how far you're going, you know what bandwidth you want, that part then is easy. Now we need to make sure that you've got a stable solution. An installation that is poorly done will cause you to have to make multiple visits, and that of course is going to be costly for both you and your customer. So you'll see some pictures as we go through this of both our standard installations as well as custom installations. So as I go through this, I'll tell you what we have that we supply as standard mounting equipment, and as you'll see through these slide presentations, how many of these have used customized or secondary third-party manufacturer pieces. We've covered clear line of sight, but a stable surface is really important. Getting to a corner, especially if you're using one of our light products, which does not have tracking, you really do want to get to the corner of the building for stability. You want to make sure that you can get power and your copper or fiber to the correct location. And then is it a safe location for installation? But also paired very tightly with that is access for maintenance. I have had a number of installations where they chose what appeared to be the most appealing line for the installation, but unfortunately it required either a cherry picker or a scissor lift or some other piece of equipment that needed to be rented in order to install it, which also means when you go to do your maintenance, you'll need a piece of equipment similar to that to go ahead and do any maintenance. So if it is possible, try and pick a location thinking into the future of maintenance that you can install it where you'll have easy access to it. I would say that most of the installations and customers I work with end up going for a non-penetrating style of mount, and that's because people are typically renting the buildings or leasing space in a building, and roof penetration or building penetration is not always allowed. I would say that probably the biggest exception to that is when we deal with either hospitals or college campuses. They seem to be more tolerant for penetrating, but just about everybody else moves to a non-penetrating style of mount. Make sure you can get roof access. You do have to carry equipment up there, so you got to make sure you can get to the roof. If you do have to go with a taller mount, make sure that you've got stability and you're not using a thinner whip mount, a whip antenna type of a mount. You'll need to get something more stable, and we'll talk more about that. No surprise here. Anything that expands and contracts, that is crumbling, that is flexible, is not going to be a good mounting location. So our problem surfaces are things like wood, old bricks, fiberglass, sheet metal. Sheet metal is atrocious. There are certain areas in the world that metal construction is not just accepted, but the preferred way of doing construction. And unfortunately, the way that corrugated metal bends and twists during the course of a day has been problematic for us. So what do we look for? Concrete blocks, poured concrete, newer construction brick, steel beams if they're on the roof. If there's someone's already installed a 4.5 inch or larger OD pipe for doing other microwave type installations, then let's mount to that if we can. So here's what we supply. It's a 3-piece universal mounting kit. It can be installed vertically or horizontally. It allows the unit to be mounted both vertically or horizontally. And these 3 pieces can be used by themselves or in conjunction with third-party mounting materials. And as we go through these slides, you'll see where they've either used all the parts of our universal mounting kit or pieces of it in order to, again, marry it up with something that came from a third-party vendor. So this is some versions of non-penetrating roof mounts that have been very successful installations. The most common are ones from Baird or ComSite that allow you to mount, have a large footprint and allow you to use larger diameter poles to go much higher, up to 10 feet in the air, and still provide the stability required for free space optics. Others are more simplistic, almost using like patio tiles or cement patio bricks in order to mount and give the stability needed. Used to an existing pole, and then they went ahead and used our universal cap and our universal pole in conjunction with that third-party bracket. Here's a good example of one of our hybrid solutions on the left-hand side, where they've mounted the AirLight, actually it's a hybrid SX, horizontally using our, and then they have a RF radio used as the backup solution. And another important part of the way free space optics operates is we can work in close proximity to all RF solutions. So if you are moving to a RF-rich environment where there is so much noise in the RF world that you can't install your unit, or you're looking at, well, how can I amp up my power in order to blow through the other guys, our products can be used in conjunction or instead of an RF solution. If the building is already at capacity for RF, take a look at FSO. We don't interfere with the RF world, and the RF world doesn't interfere with us. And you can see kind of in our hybrid solution in the lower right hand, in fact, we put our backup radio right underneath our unit, and there's no interference of the radio to our product and of our product to the radio. The left-hand side's a nice one because it shows that there are situations where you have I-beams and you can just attach unistrut to the I-beams and use our pane and tilt directly attached to the unistrut. It's also kind of an interesting picture because it was in a heavy bird environment, and as you can see they put bird spikes on there to keep the birds off of the unit. The ones on the right-hand side are just some additional looks of different installations. The AirBeam in the upper right-hand corner is actually used in conjunction with some other RF products that are at a lower level on that mount. Just an interesting installation look. If you do need to go high, and I understand there are times that you do, you need to make sure that you properly guide down this installation. As you can see, they found roughly a 10-foot pole to get the unit up above the sight line that they needed, but they had to tether it down or guy it down, which they've done a great job. This is probably my best textbook example of proper guying of a solution. A 4-point stance on this one. They used the cap from our mounting kit along with a pole that they purchased separately, and this unit has been rock solid in Florida for about 5 years now. Should you go to a what I would typically call a riskier installation location, higher up on a tower, or any tower for that matter, or a monopole, it is recommended that you go with the Strata product line with the built-in tracking and AGC. And once again, here you see third-party pole-to-pole adapters being used with our cap, and in this case a Flight Strata product. And I've tried to put some websites available if you do need to move this direction, or you want to move this direction with these types of products, that you can go to SitePro1, which is a Valmont distributor. Valmont makes some great wireless accessories. Here again you have a pole-to-pole adapter. In this case it's a cross pole. So once again they used our pole and our cap, and again a Flight Strata product here. once again, adapting to the environment that is presented. They were allowed to penetrate on the inside portion of the parapet mount here. They then found a nice sturdy pole that's longer than our standard pole and attached the unit. So some things to keep in mind in terms of stability. Again, a proper mount gives you years of success. So a 2 7/8 inch OD pipe is good to 1 meter unsupported. And you can go, if you use a 4.5 inch OD pipe, you can go 2 meters unsupported. And you can put multiple units on that size pole. So really depends on how high you need to go in order to achieve your line of sight. And we're more than happy to work with you on any of these situations, sending us pictures, sending us descriptions, letting us know where you're trying to install, any sort of parameters that the landlord and or the customer has given you for either aesthetics or weight requirements is important for us to be able to point you in the direction of third-party products that can achieve what you need to achieve for a successful installation. Now, I live in California, and we have a lot of tilt-up buildings, and what we have found is that you have to sometimes be careful, because even though the building is stable, because we don't get a lot of weight on our building rooftops, there's no accumulation of snow or anything of that nature, not all of our roofs are built extremely hard. They can feel a little bit like a trampoline. So you do have to find where the joists are and try and install across the joists as opposed to in between the joists in order to get a more stable and rigid mount. And you'll see this and you'll feel it. As you're walking on the roof, you'll feel if it's a spongy roof or a solid roof. The other thing that we always talk about is if a mount on a tower is required, which we understand these situations come up frequently, we want to be as low on that tower as possible. The lower you are, the more stable the mount will be. So if you have a choice of, oh, it's a 30-foot tower, I'll just put it on top. Well, if you can still achieve line of sight at the 15-foot mark or as close to the attachment point for the guying on that tower, you want to get as low as you can and as close to those attachment points. And I mentioned this already, and it's worth reviewing and reiterating that mounting as close to the corners of the building will minimize the diurnal movement. So the closer to the corners you can get, the less movement that the units will experience as the building does expand and contract. And they all expand and contract to a certain amount. It's just a matter of how much and how much it could affect us. Therefore, getting to the corners will definitely ensure the best installation possible. And this is just to kind of hammer home the point of solid surfaces provide solid installations. So soft, the bricks, veneers, a lot of buildings, especially modern buildings, have a lot of veneers that they put on the outside to make them look pretty, but mounting to those veneers are not going to give you the stability that you need. And recapping about doing indoor mounts, we always want to mount as close to the glass as possible. You don't want people having to go in front of it, even if it's, cleaning crews. You want to make sure that if it's as close to the window edge as possible, the less chances you have of people interrupting the signal by bumping into it or walking through the beam. You also want to, again, take a look at the coating or the tinting and be aware that that could be some attenuation you weren't prepared for. And that kind of concludes our 30-minute tour through FSO. If you would like, here's my email contact information. Please email me any questions, any pictures you have, anything that you want as a pre-installation situation. We also have a bunch of examples and videos at our YouTube. It's LightPointe Wireless on YouTube. It'll talk about a lot of our products. It'll show you AirLight-Gs. It'll show you high bridges. It'll talk about AirBeams. It'll show you, I think we have four or five different installation videos of showing people with different installations. So I do encourage you to visit that. It will definitely give your creative juices some kickstarting when you're looking at how to do your installation. And again, we welcome any pictures out of your post-installation. We'd be happy to. We do actually do some install of the months on our newsletters. So anything that you have to send us after an install, we'd love to see it. So with that, I will say thank you for attending. We really appreciate it, and we look forward to working with you in the future.
Okay, Brian, got a couple questions here.
Okay.
You mentioned about the 2-year warranty. Is that just directly through, just contact straight to LightPointe support for that?
Say that again, I'm sorry.
On the warranty, it's just contact LightPointe directly for that, yes?
Yes, yeah. What we'll do is contact us directly. What happens is for the 2-year warranty, you will see when you get your product, it will give you a welcome screen. You need to input the information and send that to us, and then that will get you the 2-year warranty. Otherwise, it's just a standard 1-year warranty, so we do ask for registration for that extra year, and then contact me for any support, or LightPointe for that matter, for support to determine if it is a warranty issue or not.
Okay. And then on the free space optics, what is the distance and the throughput speeds? Or is it just the distance that it's going to work and it's going to be full throughput, or does it degrade as long the farther out you go?
Great question. That's a really good question. So we'll talk about our non-hybrid products first on that. We're very digital. We're either on or we're off. So if you have signal strength, whether it's full bars or half bar, and I should say that on the back of our units we have a signal strength meter, which is 10 LED bars, 10 being the maximum signal strength, loss of signal being 0. Whether you have 1 bar of signal strength or 10 bars of signal strength, you will have full throughput. So signal strength does not determine bandwidth. Signal period determines bandwidth. So we are either on at full throughput or we are off at no throughput. Now, hybrid units, they have that backup using the multi-frequency rate adaptive solution. So when that unit goes into the way it's currently configured out of the box with defaults is when it hits approximately 1 bar of signal strength, meaning that we're assuming that the weather patterns are continuing to get worse, or the situation that is causing the signal strength to deteriorate is going to continue to get worse, we will fail over before you hit loss of signal. That way you will move over into the radio, at which time you then move into the radio's rate adaptive solution. So you can actually get a little bit, we normally say for let's say our Strata G product, which is the multi-beam tracking Cadillac of our FSO products, we would normally say for the utmost availability you should be right around 1 kilometer, or give or take. You can go a little bit further depending on the environment you're installing it in. However, if you looked at the hybrid LX-R5, which has the pre-installed radio attachment, with that one we could say, okay, we'll now go to 1,500 meters or 1,600 meters. So even though you're not going to have as much initial signal strength, you know that you've got your lifeline, so you can extend the distance knowing that you've got a backup in place.
And then same kind of question on the MMW systems.
Question.
As far as the distances.
Yeah. And I guess briefly, AirLight-G we look at as a 500 meter product, and we look at the hybrid SX as more of a 750 meter product. So the single beam products are roughly half the recommended distance of the larger products.
Okay. And then another question here was, even on the, if you're running fiber directly to the unit, you still need to run an Ethernet for power and for management, yes?
Correct. No matter what, you will always need at least one Cat5 cable for the power, and you will for the data portion of it. The only caveat would be if you decided to run a DC power line up to the roof directly and run it off of direct DC 48 volt.
Okay. Any other questions? Okay, don't see anything else come in. So thank you guys very much for all this. And if anyone has any questions after this,